Hello, welcome to Chapter 5, Section 4. So now that you've learned how to do long division, we have a shortcut. Now, don't get mad at me yet. The shortcut only works when you have a binomial of the form x minus k. So in our previous video, we've been dividing by things like x squared minus 3x minus 2. That doesn't count. You can't use this shortcut for those types of problems. So you did not learn the process for nothing. Okay? This only helps if you have a binomial, such as in example 1. So we have to make sure we use the k value when doing synthetic division. So we look at what we're dividing by, the x minus 2, set it equal to 0, and solve for x. So we would solve for x by adding 2 to both sides, and we get x equal to 2. Now here's how you set up your division, your synthetic division is what it's called. You put what you're dividing by in the top left-hand corner, and it gets a box. Then you take your numbers, all of your coefficients, so -1, 3, and 1, and put them in order. So we have -1, 3, 1, but we don't have a number by itself. We have x cubed, x squared, x, and no number. So we actually also have to have a 0 for that placeholder, just like we did in the long division. And then you draw a line with space. Now here's how it works. You take the first number and you bring it down. That doesn't change. Then you take -1 and multiply by that number. So -1 times 2 is -2, and you put that under the 3. Alright? Okay. Now you add down. So we have 3 minus 2 is 1. And then you do the same thing. So you're going to take your number, whatever you get, and multiply by 2, because that's what you're dividing by. So 1 times 2 is 2. You put that under the 1, and you combine down, so we get 3. Same thing again. Take your number, multiply that by 2. 3 times 2 is 6. So you put that under the 0. 0 plus 6 is 6. Now this number is special. This number is your remainder. Okay? This number is your remainder. Now, I'm going to get rid of all these circles, because our answer is whatever we got at the bottom. So we did our multiplying. We got 1, -1, 1, and 3. Now here's how you write your answer. Start from the right and go left. When you start at the right, the 3 should be a whole number. Okay, and it's positive because of the sign that's there. The 1 is the value in front of x. So we start with no number, then we get x, and that's a positive because there wasn't a negative. And then the last one is x squared. So we have no x, an x, and then an x squared going from right to left. If we had another term, you'd put an x cubed. If you had one after that, you'd put an x to the 4th, and so on and so forth. Now our remainder is going to be like what it was when we did the long division. So let's write this out as our answer. We have -x squared plus x plus 3. But then we have the number 6 divided by what we were dividing by. So that's our x minus 2 right here. So that is our final answer. And it was shorter, okay, and it gets faster once you get used to doing it over and over again. So let's do that again. Well, we have to remember, again, that we take this and we set it equal to 0, and we solve for x. Okay, and you would do that by adding 1 to both sides on this one. So the top left corner on ours now is going to be a 1. You take your coefficients and you write them down. So we have 3, -7, 4, 2, and 8. We have a line with space in between. Now to do the actual synthetic division, you first bring down that 3. Then you multiply whatever number is on the bottom by the number in the top left-hand corner. 3 times 1 is 3. That goes under the negative 7. Combine down. Negative 7 plus 3 is negative 4. Negative 4 times 1, our top left-hand corner, is negative 4. 4 minus 4 is 0. 0 times 1 is 0. 2 plus 0 is 2. And 2 times 1 is 2. 8 plus 2 is 10. And remember that that's your remainder, so put it in its own little box. Then, to get our final answer, we go from right to left. Now, all of these, except for the negative 4, are positive. So we should have plus signs. Then, we have a number for the 2, an x for the 0, an x squared for the 4, and an x cubed for the 3. So our final answer is 3x cubed minus 4x squared. We have 0x, so I'm just not going to write it because there's no point. So then we have plus 2, and then we have 10 divided by whatever we were trying to divide by to begin with, which is x minus 1. Okay, and yes, I will be doing that again. But before I do that, let's look at what is written. Okay, being able to divide polynomials helps us to factor polynomials. If the remainder is 0, so if the little right-hand box is a 0, then the binomial is a factor, and you can just say that it's a factor. So, for instance, if you have something like example 3, where it's asking you to determine whether the linear binomial is a factor, then we can do that. So the first thing we have to do to determine whether x minus 3 is a factor of this equation is take our x minus 3 and set it equal to 0 and solve for x. So x equals 3. Alright, so now we know what's in our top left-hand corner. We have a 3. Then we write down our coefficients. So we have 1x squared, 6x's, and negative 12. So our goal is to see if we end up with a 0 right here. Okay, so I'm not going to write it yet. So the first thing we do is bring down the 1. 1 times 3 is 3. Then we add down, so 6 plus 3 is 9. Alright, well 9 times 3 is 27. 27 minus 12 is 15. Oh no, that's not equal to 0. So our answer is no. X minus 3 is not a factor of x squared plus 6x minus 12. It can't be, because the remainder is not 0. Let's do that again. We have x plus 3 here, and we're trying to see if that's a factor of that equation that I'm not going to read. We have x plus 3, set it equal to 0, and solve for x, so we subtract 3, and x is negative 3. So I'm going to speed up our process a little bit. We're going to have negative 3 in the top left-hand corner, and we're going to take our coefficients and write them down in order. So we have a 2, x to the 4th, 10x cubed, 11x squared, negative 1x, and 6. So, we take our 2 and we bring it down. That's always the first step. Then we multiply the 2 by the number in the top left-hand corner, and we get negative 6. 10 minus 6 is 4. 4 times negative 3 is negative 12. Negative 12 plus 11 is negative 1. Negative 1 times negative 3 is a positive 3. So negative 1 plus 3 is 2. 2 times negative 3 is negative 6, and 6 minus 6 is 0. That makes us very happy. That means that the answer is yes. Because the remainder is 0. You're not left with anything. Alright, so that's synthetic division. Now, the other part of this section is factoring. And because you now know how to factor, you can see if a number, or if a factor, is actually a factor of the equation. We have to master special patterns. So let's go on to the back. We have the sum of 2 cubes and the difference of 2 cubes. And I'm going to show you how to use this. But first, we need to review factoring a difference of squares. Okay, so we have this equation, a squared minus b squared is equal to a plus b times a minus b. Now, remember before we did this by just square rooting both sides. and saying we'll have a positive version and a negative version because we're taking a square root. And that's still true. But if you're going to set this up the way that it intends to be done, they want you to figure out what is the square root of 9x squared. Well, the square root of 9x squared is 3x. What is the square root of 16? 4. Then you take your a, which is the 3x, and your b, the 4, and you plug it in to this formula here. So it says that a plus b and a minus b are our factors. So in other words, 3x, which is a, plus 4, which is b, is one of them, and then 3x minus 4 is the other. Not so bad. Now, let's do that with example 6 as well. So what is the square root of 16x to the 4th? That is actually 4x squared. And the square root of negative of 81 is 9. So let's do that. We take our a, so our 4x squared, and add it to b, which is 9, and we subtract it. Well, that's all fine and dandy, but now 4x squared minus 9 is also a perfect difference of squares. So we need to do the same thing again. What's the square root of 4x squared? It's 2x. What's the square root of negative 9? 3. So here we get 2x plus 3 and 2x minus 3. Now what we're doing is we're taking this and that becomes all of that. So our final answer needs this, this, and that. It'll be 4x squared plus 9 times 2x plus 3 times 2x minus 3. That is it completely factored. That is it completely factored. Now, we need to be able to factor the sum and difference of cubes as well. So, right here we have x cubed minus 64. Well, that's the same thing as saying that we have x cubed minus 4 cubed, right? Because the cube root of 64 is 4. So if you put that into the formula, and that's a difference of squares, so we're looking at, a difference of cubes, so we're looking at this formula right here. Our a is x, our b is 4. So we plug it in. We get a minus b, so x minus 4. Then we get times a squared, so x squared, plus a times b, so 4 times x, plus b squared. B squared is 4 squared is 16. So that's our answer. We can do the same thing here in example 8. The only difference for example 8 is that when you do it, you have to take out something first. Okay, remember, we always take out a GCF first. Is there anything that goes into negative 16x to the 5th and negative 250x squared? The correct answer is yes. We can take out a negative 2x squared. When we take out a negative 2x squared, we get 8x cubed minus 125. Well, the good news here is that if I'm asking you to do the sum and difference of cubes, you know that it's going to end up being a perfect cube, right? So 125 is 5 cubed, and 8x cubed is 2x cubed. So we're going to rewrite it as such, and I'm just going to do what's in here. So we have 2x cubed and 5 cubed. So we're going to use that exact formula again. So we end up with a plus b, a minus b, so 2x minus 5. Then we end up with a squared, so 2x squared is 4x squared. Then a times b, so basically 5 times 2, so we get 10x. And then 5 squared is 25. But we can't forget that this is still there. So that is our final answer. And it really didn't take a lot of work. It just took a little bit of time to use the formula. So let's go on to factor by grouping, because we've done this. Here's your reminder. You group the first two and the last two, and you take out what you can. So what can you take out of x cubed minus 2x squared? Remember, it's the lowest exponent, so we can take out an x squared. And we're left with x minus 2. What can you take out of negative 9x plus 18? Well, they both have a negative 9 in it, so we have negative 9, and you get x minus 2. So remember, you take the inside, that's one of your factors, and then the outside is your other. But, surprise, surprise, x squared minus 9 is a difference of squares. So we have to change that. X squared minus 9, I'm going to come over here and do, is the same thing as x squared minus 3 squared. So remember, we have a plus b and a minus b. So x plus 3 and x minus 3. Oops, that's a 3. Then we can take that and come back over here. So we have x minus 2 times what we just got. So x plus 3, x minus 3. And there we go. That's our answer. So once you know the shortcut, it's really easy to use it. Last one, factor this, group the first two and the last two. We can take out z cubed to get z minus 1. We can take out a negative 64 to again get z minus 1. Inside is one of our factors, so we have z minus 1. Outside is the other. So you have z cubed minus 64. Z cubed minus 64, that is a that is a difference of cubes. So we're going to come over here just like we did before on the last one. We're going to say z cubed minus 64 is equal to z cubed minus 4 cubed. Okay, so we use that formula. That's a minus b, so z minus 4 times a squared plus a times b, so 4z plus b squared, so 16. And we take that and we replace what was already there. So z minus 1 times z minus 4 times z squared plus 4z plus 16. And now you can factor big things. Have a great day.